Hi guys, Mo here. So today we're going to show you some neat little injector stuff. You've seen some of my injector videos on the flow bench, but we're not going to focus so much with the flow bench as much as we're going to show you some oscilloscope action with some different scoping on injectors. So we're going to show you some electrical current testing on some injectors and show you the difference there with some amp draw on some injectors and show you why not to buy cheap injectors. Okay, what we have here is the different waveforms. We have a 42-pound injector hooked up here pulsing. The yellow line is the pulse width. It's the transistor on, the transistor off. This blue line is the coil winding up the pintle opening, so we see mechanical movement, which is this little hump right here, then the peak amperage that it's hitting, and then the actual closing. So that's what we're seeing in this waveform right here. So in this, I had all my settings, you can look all this up in other people's videos and whatnot, so I have it all zoomed in, and I can actually look out, but I have this zoomed in so we can see it nice and clear, but that's what that is there. So to show you a different injector, we'll take that 42-pound injector off. Notice where the pintle hump movement is. You'll have to bear with me. Okay, and there's a second 42-pound injector. So notice, very similar. And also down here, this is telling us our peak. It's telling millivolts, but we can convert that to amp draw. So it's actually 0.62 amps on the peak. So both of those 42-pound injectors were high impedance injectors, hence the 0.6 amps. Now I have a 120 pound per hour injector that is low impedance, and notice the amp draw has gone up. Notice the similar little pintle hump there in mechanical movement and the peak amperage there. And you can see it's a lot higher of an amp draw due to a low impedance injector has a lot higher of an amp draw. So that's the difference in a low impedance injector. But again, notice where the pintle hump, pay attention to all of these, where the pintle hump is and the amp draw. So I'll switch that out real quick. Okay, and now I've switched that out. And the reason it's jumping on my screen is it's catching it in time. So notice the same amp there, and the pintle hump is in the same spot. Another low impedance 120 pound per hour injector. Okay, now we have one of our cheap knockoff 60-pound injectors. I've actually flowed these before in one of my other videos. And so we've got this hooked up. It is pulling 0.66, 0.68 amps. You can see the pintle hump very early right here, very hard to see, but there it is right there. That's why I have this zoomed in for all the other injectors, so you can actually see the pintle hump. It's right there. And then as it comes up, and its peak amperage in here, but it's gradual come up, and there it is. But what I want you to notice is when I change to one of the other 60 injectors in this set. Okay, so now I've changed from that 60 to this 60, and let's see where that pintle hump is. So now, instead of the pintle hump being really early, it has shifted to later in the pulse width. And look at that amp draw. The amp draw has gone from 0.66 to 0.86 to 0.88. So higher amp draw, and the pintle hump where it physically is opening is later. Also, these are the same injectors that when we put more pressure to them, it changed their dynamic flow. They actually went down and started locking up. So you should watch that video to see. Now also, this pintle hump can change that pintle hump can change in time when we put pressure behind these injectors. So that would be another video. We can actually put it in the bench and then apply pressure behind the injector and watch where this hump goes with pressure behind it. So, yep. Okay, here we have a real Ford 24-pound injector. Ford part number and whatnot, obviously made by Denso, it looks like, on there. But anyway, these are found in the older Fords, whatnot. You can find them in junkyards. Anyway, again, you can see the pintle hump, and it comes out up and is really flat. 0.6, 0.62 amps. At some point in this car, somebody had replaced one of the injectors with some whatever, this injector. It does not have a part number on it at all. There's no part number on this injector. It is trying to be this injector, but it does not have a part number. Notice the pintle hump is later in the cycle, and the amp draw just continues to rise. It ends up near the same peak, but way later in the pulse width. So, but the pintle hump is later in the pulse width, and then the amp draw just continues to rise. It's not that nice flat, you know, come peak, hold. So, yeah, again, just a cheap knockoff injector trying to be, you know, what this is. And these injectors you can get from the junkyard and then have them clean. So, yep. Don't buy cheap injectors, folks. So there you guys go. There's a little electrical test on different injectors to show you why you should not buy cheap injectors. If you watch some of my other videos, you've seen where I flow test different injectors to show the differences and why you shouldn't buy cheap injectors. I don't know why people would cheap out on something about, you know, something precise like fuel control. But anyway, there you have it. I'm Mo. Thanks for watching my video.